Hello, my dear students. We are going to learn about momentum today. Momentum. The formula is mass multiplied by velocity. Any object which is moving will have the momentum. In simple, right? Simple case. Now here we have a car, and the car is not moving, 0 meter per second, but it has the mass. But the momentum is zero here. The car started moving. It is moving at 2 meter per second. Now if you want to find the momentum, 500 multiplied by 2, 1000. Unit is kilogram meter per second because mass and here is velocity. So as the speed increases, the momentum increases. At the same time, not only the velocity, you can increase the mass. Now you are dealing with the truck and same speed. The truck mass 2000 kilogram and the object is moving at the same speed. Now if you multiply mass and velocity, 2000 multiplied by 2, here 4000 kilogram meter per second. Now you see here, compare the value. Here 1000 kilogram meter per second, here 4000 kilogram meter per second. What is the reason? Why, though the speed is the same, the two different momentum, it is because the mass of an object affects the momentum. So always you think about the mass and the velocity. Both factors will affect the momentum. This is the reason on the road, the truck velocity will be 80 kilometer per hour, and for car velocity 140 kilometer per hour. So they reduce the speed, the maximum limit, they reduce the limit for the truck because it has more mass, so the momentum will be higher. Here it has the less speed, less velocity. It is because the mass of the car comparing the truck, it is less, so the impact will be less. So that is the reason they are not allowing the truck to increase their speed, because the momentum will be greater. The momentum create the impact, a big impact onto another object. It will transfer its energy to another object, so the other object will absorb the energy. So it is the reason the collisions are happened. Now we can do the conservation of momentum. What is conservation of momentum? Before collision momentum is equal to after collision momentum. We can see this in detail here. There are two objects, truck and a car. I want to take a truck mass as m1 and the car mass m2, and I want to take the velocity of the truck, initial velocity u1, here is u2. This addition will be equal to after collision momentum of the truck. What is that? m1. The mass of the car m2 will not change, but the velocity is final velocity v1 and v2. What it is actually, just you need to find the momentum of these two objects and momentum of these two objects, and you equal this, and both sides will be the same, should be the same. We can see it. Now here 3000 kilogram 10 meter per second. I'm going to apply this value here, 3000 kilogram. And what is the initial velocity of the truck? 10, it is given, plus what is the mass of the car? 1000. Velocity, initial velocity 0. What is the mass of the truck? It will not change, it is 3000. Velocity, what is the velocity once the truck hits the car, and still it is moving, but what is the speed? How much the speed will be? We can find it here, v1. It is not given. What is the mass of the car here? 1000. What is the speed, velocity? 15. It is given. Because when the truck hits the car and it transfers its energy, it transfers its momentum. So as the energy is transferred, the car is moving with the velocity of 15 meter per second. It is the impact. Okay, now we can multiply 30,000 plus 0 is equal to 3,000 v1 plus 15,000. So here 3,000 v1, 30,000 minus 15,000. So this will be 3,000 v1 is equal to 15,000. v1 is equal to 15,000 divided by 3,000, 5 meter per second. So the truck speed is reduced. The truck speed reduced. Now you can substitute the truck speed here. This side, how much value before collision? The total momentum 30,000. Here before collision 30,000 is equal to, here 3,000 multiplied by 5 is equal to 15,000, plus the car's, after collision the car's momentum is also 15,000. Now you can see here 15,000, 15,000 is 30,000. The other side is also 13,000. This is the reason we say conservation of momentum. That means the momentum is conserved, will not change before collision, after collision will be the same. The total value will be the same. Okay, is this clear? Here is another example. From a rifle of mass 4 kg, a bullet of mass 50 gram is fired with an initial velocity of 35 meter per second. 35 meter per second. Calculate the initial recoil velocity of the rifle. Recoil, the gun moves backward, is called a recoil. Okay, so we are going to find the velocity here. How much velocity? Now you see here, momentum before is equal to momentum after, will be the same. Before momentum, there was a mass of the gun plus mass of the bullet into velocity. This will be zero. Velocity is there is no movement in the gun and the bullet, so this v is 0. So anything is multiplied by 0 will be 0. So this side momentum before will be 0. After this momentum, after momentum, that is after firing, there will be again two objects. So the mass of the gun plus the velocity of the gun plus mass of bullet, velocity of bullet. When you add these two, the momentum must be 0. That is what I say, momentum is conserved. Momentum is conserved, which means we have to prove 0. The addition of these two must be 0. So how can we prove here? So the mass of gun is given 4 kilogram multiplied by the velocity of the gun I have to find out, plus the mass of bullet 50 gram. Gram must be converted to kilogram, and velocity of bullet is 35 is equal to 0 here. So 4 Vg plus 0.05 multiplied by 35. So 0 is equal to 4 Vg plus 1.75. So 4 Vg is equal to negative 1.75. So Vg, the velocity of gun, negative 1.75 divided by 4. So Vg is equal to 4.0. Negative 0.44 meter per second. So here the value, the gun velocity is negative because the object is moving to the left. As it is moving to the left, negative x direction, so our answer is correct. Our prediction is correct. Even the movement, the backward movement must be less, right? Because the mass of gun is greater, so the velocity should be less. The speed, the backward velocity, the recoil velocity must be less because the mass of gun is more. Otherwise, our shoulder will get hurt if it is a higher velocity. That's what we are increasing the mass of the gun to reduce the recoil velocity. Okay, now if you want, what you can do, you substitute this value, the velocity of gun value here, negative 0.44 plus this multiplication value is 1.75. If you multiply, you will get almost zero, because if zero value is not coming, that means you should know here we have rounded off the value. So but if it is not rounded off, then the value must be zero. So momentum after is equal to momentum before, zero. Hence we have proved, right? Then we have some other type of question. For example, here is a car and here is another car. Okay, here it is 500 kilogram. Here it is 1000 kilogram. Initially the car is at rest. So initial velocity. Here initial velocity u1 10 meter per second. Here initial velocity u2 0. Okay, now as it is moving and it finally it hits. After hitting, the two cars are joined together. Imagine the two cars are joined together like this and it is moving to the right. What velocity? They're asking what is the velocity of the car. So of course the 10 meter per second will not be there because the mass is increased now, right? So how can we find this? First, momentum before, we can find what is momentum before. Now here the mass of first car and mass of second car. So m1 u1 plus m2 u2. This car 0, of course, so there is no momentum. And m1 u1. Here what is the mass? 500. What is u1? 10. So 5000 kg meter per second. This is the value before collision. So after collision, it should be 5000 kilogram meter per second. Okay, how can we find? After collision diagram is here. Here is the after collision diagram. Now, after momentum, collision momentum, after momentum, here the two objects are joined. That is M1, M2 is joined together. So the mass will become one system, that is M into V, M1 plus M2. This one is the mass multiplied by the velocity. Okay, so you know the mass, total mass now will be 1500 and the velocity I don't know, I have to find out. So conservation of momentum says momentum before collision is equal to momentum after collision. So using, now it is momentum before collision, momentum after collision. Using this you can solve for velocity v. So v will be 5000 divided by 1500 will be how much? So 3 times 3.3 meter per second. So the velocity value is reduced from 10 meter per second to 3.3 meter per second. It is because the car is not, first condition, the first thing, the car is not moving. Second, after when the car M1 is being hit with the M2, it is joined now. It is joined. So the total mass is increased. So the car cannot move with the same velocity like before, like it was before 10. Now it is 3.3. It is reduced, right? Because it should obey the conservation of momentum. Hope you understand. If you have any doubt, please you can post your comments. Okay, thank you very much.